Hi guys. So I'm going to go over our second free response question for this week where we're reviewing inference, and this is from the 2014 exam. This is question number 5. I chose this question intentionally because it tends to be a question that students struggle with, and it's really easy to pick the wrong test to do on this problem. So let's just look through the problem. So the problem says a researcher conducted a study to investigate whether local car dealers tend to charge women more than men for the same car model. Using information from the county tax collector's records, the researcher randomly selected one man and one woman from among everyone who had purchased the same model of an identically equipped car from the same dealer. The process was repeated for a total of 8 randomly selected car models. The purchase prices and the differences, women minus man, are shown in the table below. And then they give you that, and they give you all of these summary statistics. And then the question says, do the data provide convincing evidence that on average women pay more than men for the same car model? Okay, so this is going to be a test because it's talking about providing evidence. And then once we know it's a test, we decide mean or proportions. Well, since they're talking about means throughout everything, we know it's means. So the challenge with this one is whether it's a 2 sample. So remember, if it's means, your choices are 1 sample. This is not going to be a 1 sample since we're comparing things. 2 sample or matched pairs. Okay. So a lot of people, when you initially see this problem, you would jump to 2 sample because you see, oh, we're just comparing the men and the women and we're just going to get the differences. So the reason that this is a matched pairs as opposed to a 2 sample is because of what they say right here. Your sample, you're not taking a random sample of women and then a random sample of men. If I did that, if I took a random sample of women and a random sample of men and then compared how much they paid for cars, that would be a 2 sample. The reason this is matched pairs is because I'm randomly selecting 8 car models. So the car models are my sample, and then what I'm doing is I'm comparing how much for each of those models, how much women paid and how much men paid. So each of these 8 things represents my sample. And then I'm comparing the difference in the prices for both. So like I said, this one's a little tricky, but that's why it's a matched pairs test as opposed to a 2 sample. So let's get into the test. So our population, as I kind of stated earlier, is car models, okay, the model of that particular car. Parameter is the mean difference in purchase price, men and women. Anytime you're doing a matched pairs test, just remember you're always going to use that word difference. And then this is a matched pairs T test. Remember, means are always a T. I only have 2 conditions I have to check. The first one is SRS, and that is given right here because it says randomly selected car models. So SRS is met, and then my second check is approximately normal. So remember, approximately normal for means, first, they tell you. They do not tell us it's approximately normal. They don't tell you it's approximately normal. The second thing would be to go to the central limit theorem, but my sample size is only 8. So remember, your third thing to do is you can make a quantile plot, which you can do here because you have all of the data, you have all of the differences. So if you wanted to, you could make a quantile plot, or they've already made a dot plot for you. You could just use the dot plot as evidence. So even though this doesn't look approximately normal, as long as it seems reasonably symmetric, we'll say that it's good. Okay, so approximately normal, again, if you wanted to, you could make a quantile of all the differences, or you could just use the box plot they already give you. And those are my only 2 conditions. And then I'm going to go ahead and write the ho and the ha. So the ho is that mu equals 0, because that's saying that there is no difference between the men and the women. Okay, so remember your mu is the mean difference. And the ha, the question says that women pay more than men. And since the differences are calculated as a women minus man, that's why the alternative would be greater than 0, because you want to see if they pay more. So now I just get my t value. So my t value, I take the mean difference, okay, and this is in terms of hundreds. But so how I got the mean they give you right here is 585, so you don't need to calculate that. So I do 585 minus 0, which is just 585, and then the standard deviation, which they always give you over the square root of 8. So remember, your sample size is the 8 cars. That's your t-value. And then your alternative is greater than, so you only have to get the area on one side. So from there, I drew my little sketch, and then I'm going to do TCDF from 3.12 to 99. Don't forget, when you're doing TCDF, guys, you also have to put in your degrees of freedom. This is your sample size minus 1, so that's why this is 7. We get a really small p-value here. It's 0.008. So remember, if the p is low, we reject the HO. So they don't give us an alpha to use. So again, I'm just going to go back to my alpha of 0.05. So my p is less than or equal to alpha of 0.05. Make sure you write that out. So we're going to reject. We reject the HO. So if you ever get stuck with that, just go back to your HO and HA. So we reject that the mean difference in purchase price of men and women for the same car model is 0. We're rejecting that. If we're rejecting that, we have evidence towards the alternative. So we have evidence that women pay more. So like I said, the trickiest thing about that one is deciding the test. So that was 2014, number 5. I'll talk to you guys again soon.